green, I think. Yeah. All right. So we will see if that works. All right, so let's go ahead and get started. I think Greta should be trying to log back in here. If not, hopefully the streaming will work. Okay, so I had one question. I see James joined in. Hey, James. I had one question about 1, 2, number 23, so we'll go ahead and do that first. So maybe try switching that. I have a nice pen to write on my screen with. I'm trying to get it to work here. Ah, nice. I don't have that. Okay. Greta, I hope you can hear us a little bit better. Oh, there we go. 1, 2, and this is number 23. So we have 2x to the 4th power minus 4x, yay, Greta, to the 3rd power. And we want to evaluate when x equals -1. Something with the vertical lines. Okay, so what we're going to do for this is we're going to plug it in, right? We know that we're just evaluating this expression, so we need to plug x in. And this is where the how do you plug in a negative number comes into play. So that's really kind of the key to this problem. So 2, and then we have x to the 4th power. Well, when we have x to the 4th power written like this and we're plugging in a number, we actually need to keep the negative inside the parenthesis because the 4th power applies to the whole -1. It's not 1 to the 4th power negative. If that makes sense. Okay. And then with the second one, we're going to do the same thing. When we're substituting a variable, we want to keep the negative number, the negative with the number. Okay. Hold on just a second. I'm going to get a drink. So you guys can probably figure this out. Sorry, I hope that sounds a little better. So you get, yeah, this is 1.2, number 23. This is on page 14 in your book. So your 23 is different. All right, you check that while we yeah, so you check that out. Okay, so when we have negative, so we input it, we substituted, right? So now we have to do order of operations. So we don't have parentheses per se to do anything in. So the first thing we have to do is exponents, right? So we're going to do -1 to the 4th power, which a negative times a negative times a negative is a positive, right? So we should get 2 times +1. And then -4. And then -3 to the 3rd power is -1. Okay. We'll have to figure that out, Elijah. Okay, so we have 2 times 1 is just 1, right? 4 times -1 is -4. And then when we subtract a negative, that's just like adding a positive, right? So this should be 6. So Elijah, you did the wrong ones? Yep. Yes, 1 to the power of something is just 1. -1 gets a little bit tricky because if it's -1 to like an even number, that would be like squared. It becomes +1 because it's -1 times -1. So the negative, yep, yep. Daniel, did that, yeah. Daniel, did that make sense? Daniel's got a cold, so he's chatting. While Daniel's typing, Greta or James, did you guys have any questions? All right, perfect, Daniel. On 1, 2, or 1, 3? Well, no. Oh, yeah. So do you see how 21 has that red circle around it? That means that in the back of the book, if you wanted to check your answer to that, you need to go to the red section. And and then all the other odd ones are in the back. All right, great, James and Greta. Do you have fun with all of the factoring and, or not factoring, the lots of solving, right? Oh, we have participant 2 and 4. Hello. Okay. Yes. All right, so what we're going to do is we're going to go over 1.4. I was telling the couple of people that were here earlier, I'm kind of playing around with the idea. I'm actually I'm recording this help session or this call right now, and I'll put that up on YouTube. Yeah, that would be good. Oh, that would be, that would not be good. Um, so I'm actually playing around with the idea of recording some short, like we didn't finish 1.4, so maybe I could record that on Tuesday and you guys can watch it on YouTube so that you can get more of your homework done earlier in the week. And then we'd still have Friday for you to come ask questions and do any follow-up. So I might play around with that next week. So don't be surprised if you get an email from me. And we'll talk about this on class on Monday, but I might record something. It's not going to be an hour long, probably 10 or 15 minutes of the next section so that you can keep going on your homework. So, but for today, we are going to go over 1.4. And we talked, I think, really, really quickly about this on Friday or on Monday. I think we kind of just threw in 2 minutes about it. But 1.4, I have, for the first thing in my notes, I have check out the chart on page 26. So the chart there is a bunch of formulas that are really standard formulas. So you have formulas for distance, temperature, area of the triangle, area of a rectangle, all kinds of things. And the reason that they put that chart in here is because what we're going to be talking about is rewriting formulas and equations. Okay, so if, for example, you have, so this is kind of the point of why we're doing this. If you're a person that's like, why are we doing this? This is the why. Okay, so say I looked at my chart and I know that let's see. Let's do temperature because that's a common one. I know that the formula for temperature is that the degrees in Fahrenheit equals 9/5 times the degrees in Celsius plus 32. Okay, so that's kind of the standard formula. There is a formula to convert it. And it kind of makes sense, right? It's that when you're a kid and you're like, it's freezing outside, and they say, oh, it's if it's 0 degrees Celsius, then it's 32 degrees Fahrenheit. And that's the, freezing point. That's why our freezing point isn't 0 like in the Celsius scale. Well, that's a whole nother formula. But so that, that's the formula. So, but what if instead of we're measuring in Celsius, we're taking measurements in Fahrenheit, and we need to convert it. How would we do that? And we do that by rewriting the formula. So right now, this equation is solved for Fahrenheit, right? We put in some Celsius temperature measurement, and we get out what the degrees are in Fahrenheit. But what if we're measuring everything in Fahrenheit and we really need it in Celsius? What we would do is we would you could do everything backwards. So it would be kind of crazy. I mean, say you measured, you were, in science class, and you took, a measurement in Fahrenheit, and it was 68, and you wanted to solve for it. You could solve for it. But what if you... Well, we would subtract 32 first, but let's say we weren't just taking one measurement, we were taking lots of measurements. And so we don't want to sit there every single time and resolve the equation. We can actually rewrite this formula in terms of Celsius. So that's what we're going to do. Oops, erased that. We're going to rewrite these formulas in other forms. So if I wanted to solve this for Celsius, the same kind of rules apply that for solving equations. So let's cross this off here. So right now, solved for Fahrenheit. I want to solve for Celsius. So what I need to do is I need to get rid of everything that's happening to my Celsius variable right now, right? So Elijah asked a question, which is good. Do I get rid of the 9/5 first or the 32 first? Technically, you could do either, but it's going to be way easier on you to start with moving the 32 to the other side of the equation. Because the 9/5, we're probably going to have to either deal with multiplying by a reciprocal, we've got a fraction going on, and typically we get rid of any addition and subtraction terms first, and that makes it easier. So we're going to subtract 32 from both sides. So our new equation would be Fahrenheit minus 32 equals 9/5 times Celsius. Okay, so then now I have to figure out how to get rid of this 9/5. Well, I'm going to use the power of the reciprocal to get rid of 9/5. So the reciprocal of 9/5 is 5/9. And if I multiply a fraction by its reciprocal, then I just get 1. But if I do that to the right-hand side, I also have to multiply the left-hand side by the reciprocal. And when I'm multiplying it, I'm not just multiplying it by the Fahrenheit, I have to also multiply this subtracting 32. So you see, I added the 5/9, but I also put parentheses around f minus 32 because it's multiplying both. So I'm left over with 5/9 times f minus 32 equals Celsius. So now if I'm doing a bunch of science problems and I'm taking measurements in Fahrenheit and I'm needing to convert them to Celsius, I can just plug them in. My first one was 68. I can plug that in, figure out what the degrees Celsius. My next measurement was 105. I can plug that in, get my Celsius out. So that's kind of the why of what we're doing in this section. And you actually do use this in science classes. I mean, I don't know. I know in physics you use it a lot. But there are other instances where you have to rewrite formulas to help them get to the variable that you're varying. We're varying the Fahrenheit and we want to figure out what Celsius is. Any questions about that? Awesome. We good? All right, so let's try a couple more examples just to practice some different ways that we can solve our equations here. Let's clear this off. Okay, so instead of giving you an exact formula, which we could do, we're talking about rewriting general equations. So if I have 9y minus 4x equals negative 30, and I wanted to solve the equation for y, am I able to do that? Well, the answer is yes, you are. So let's work on that, all right? So I'll write it up here. 9y minus 4x equals negative 30. Okay. So I need to get y all by itself. I'm trying to solve for y. Right now, y is being multiplied by 9 and then subtracted by 4x. So the first thing that I want to do is I want to send my 4x to the other side. So I'm going to do that by adding 4x to both sides of my equation. In general, if you can get rid of all the terms that don't have anything to do with your y, if you can send them all to the other side, that's what you want to do first. Okay, so I'm left over with 9y equals, and you could write this in either order, but I'm going to write 4x minus 30. Then I have a pretty simple step from here, right? I have 9y, and I need to just solve for y. So I'm going to divide by 9. And I find that y equals 4x minus 30 divided by 9. Okay, so one point I wanted to point out is this equation right here and this equation that we solved for should be the same equation. Okay, they're just written in different forms. We didn't do anything to the equation to change it. We're just rewriting it. For those of you who have so they're the same equation. You plug in x equals 8 to the one at the top or the one at the bottom, and you should end up with the same y. So you can check your work again. If this is something important that you need to make sure that you've rewritten your formula, you can plug it into both equations and see if you get the right answer. Also, if any of you have and I can't remember who does and who doesn't, but if any of you have a TI 8384 calculator, if you want to graph, another reason for doing this is if you want to graph these equations, you have to have it in this form, y equals something. So that's another reason to know how to do this. Other graphing programs don't always make you do this, but if you have those calculators, it does make you put it in this type of form. So there's a couple purposes for why to know how to do this. And it's just, like I said, one is if you're solving for something, one is for your calculator. All right, so we rewrote it, and now it says find the value for y, or find the value of y for the x. So this is kind of the easy peasy part. You've rewritten the equation, so now you're going to substitute in x equals 8, right? So you're going to plug that in right here. So a really quick 4 times 8 minus 30 over 9, right? And then I get 2/9. 4 times 8 is 32. 32 minus 30 is 2. And then that's time. Any questions about that? Nope. All right. All right, so let's try number 2 because it's a little bit trickier. Of course, right? Number 2 gets a little bit trickier for you. Okay, number 2 says we have 9y plus 6xy equals 30. It's kind of familiar from our one above, but the first thing I notice is that I have I'm trying to solve for y, and I have y in both my terms. So that kind of adds a new dimension to this, right? How am I going to get y by itself when it's in two different terms, but they're not like terms, right? I can't add 9y and 6xy together because they're not like terms, and we talked about that on Monday. So how in the world am I going to get y by itself? Well, guess what? It comes down to my favorite property. You knew it was going to come back, right? So we talked about the distributed property, but the reverse of that is that we can pull terms out, right? What if we pull a y out of both of these terms? Let's pull y out. Huh? Yeah, so let's pull y out. So if I pull a y out of 9y, I'm left over with 9. And if I pull a y, and then add, and I pull a y out of 6xy, I'm left with 6x. And that equals 30. So how does this help me? Well, now I have y all by itself times this, the parentheses, what's in the parentheses. So now I have y times what's in the parentheses equals 30. Okay? Well, almost. I still need to get y all the way by itself. I need it to be y equals something. So right now, y is being multiplied by this stuff in the parentheses. Whenever a number or whenever a variable is being multiplied by something and you want to get rid of it, we usually do that by dividing. So what if I divide this y times 9 plus 6x in parentheses? What if I divide it by 9 plus 6x? Yeah, the y is left all alone, right? But if I do that to the left side, I've got to do that to the right side, right? So right now, it's y times the stuff in the parentheses divided by the stuff in the parentheses. The stuff in the parentheses is important, but so by dividing by it, I'm able to cross it off, and I am left with y equals 30 times 9 plus 6x. Is it this part here, Elijah? The what? So in my first step, I pulled out y. All right, I pulled y out. So now I have y times something. Think about it. If you have, before we had 9 times y, right? So to get rid of the 9, we just divide it by 9, and that crosses out. Well, instead of having 9 times y, I have 9 plus 6x times y. So to get rid of the 9 plus 6x, I need to divide by the 9 plus 6x. Yeah, kind of a tricky little step in there. Okay. So let's try number 3. It kind of reiterates this again. So let's try out number 3. We have 4x plus 7y plus 5xy equals 0. Oh, and I apologize. I completely missed the step of plugging in x equals -6. Okay. Yeah, so I'm sorry, I missed doing that. When I calculated, I got y equals -10/9 when I plugged in that. So I apologize. All right, so let's look at example number 3. So we have 4x, huh? Yeah. So when I have 4x plus 7y plus 7xy equals 0, and I need to solve for y, I'm like, okay, great. Y is in 2 terms again, and they're not like terms. But I do notice I have this 4x hanging out over here, and that doesn't have a y in it. So I can send that to the other side, right? I don't have to worry about pulling a y out of that. So to get rid of 4x on the left-hand side, I'm going to subtract both sides by 4x. So my new equation is 7y plus 5xy equals negative 4x, because it was just 0 over here, right? So now this looks an awful lot like example number 2. I have 7y plus 5xy. I've got a y in both terms, but they're not like terms. I can't add them together. So what am I going to do? I'm going to pull the y out. Okay. I'm going to pull the y out of 7y and pull the y out of 5xy. I'm going to pause for a second. Sorry about that. I guess I'm not used to talking this much in the morning. All right, so I'm going to pull the y out of both of those. So when I pull y out of 7y, I'm left over with 7. When I pull y out of 5xy, I just get 5x equals negative 4x. Okay? So now we're kind of to the point of y times the stuff in the parentheses equals negative 4x. And the stuff in the parentheses is important, but not right now for our solving purposes, right? So to get rid of the parentheses, I'm going to divide by 7 plus 5x. And if I do that to the left-hand side, I also have to do that to the right-hand side. So what that leaves me with is, I'm running out of space, equals negative 4x divided by 7 plus 5x. Okay, so again, this equation and my original equation that I just circled over top of should be the same thing. So if I put x equals 1 in either equation, I should end up with the same solution. Okay, so if I plug in x equals 1 here, I'm going to get negative 4 times 1 divided by 7 plus 5 times 1. Sorry for the words everywhere. So I end up with negative 4/12, otherwise known as negative 1/3, or negative 0.3333 for those decimal or for the calculator people. Okay, and just to kind of prove that point, how did I get 12 in the denominator? I had 7 plus 5 times 1. So 5 times 1 is 5. Yep. So, well, I know. So just to kind of prove the point, my original equation was 4, and let me erase it off here so maybe you can actually see what I'm doing. So this was my original equation, was this 4x plus 7y plus 5xy. So to double check yourself, you could say, all right, 4x plus 7y plus 5xy equals 0. And we know x equals 1, right? So if I plug in x equals 1, I'm going to get 4 times 1 plus 7 times y plus 5 times 1 times y equals 0. I'm running out of room. I'll have to erase a little bit here. Exactly. I'm just overemphasizing here. All right, so if I solve this, I get 4 plus 7y plus 5y equals 0. So 7y plus 5y is 12y plus 4 equals 0. Man, I'm running out of room all over the place. I usually like to keep things neater than this. Sorry for this, guys. Okay, so I need to send 4 to the other side. And then I have 12y equals negative 4, or y equals negative 4 divided by 12, or negative 1/3. So that's just kind of the proof that either way you write the equation, and I already erased what the rewritten formula was, but either way you write the equation, it should give you the same solution. Okay. Did I lose everybody? You guys good? Everybody else out there on Team Viewerland, you guys still awake? All right, good. Awesome. Great. Thank you. All right, so last example, and then we'll get you on your way. Last example is kind of the trick example, and I will fully admit that when I get to these sometimes, now that I've done it a few times, I remember, but it's one of those things like, how do I do that again? Oh yeah, that's how I do it. So what happens if what I'm solving for, I'm still solving for y, is in the denominator? So I have 1 over x plus 1 over y equals 1. And this looks like a nice, simple, elegant equation, right? But I got to solve for y, and it's in the denominator. And how in the world am I going to do that? Always makes it harder, right? Can't be the easy ones. Well, the reciprocal would work, except well, we might be able to try that out, Elijah. One of the things, though, that can also, reciprocal is actually a really good answer because whenever we have things in the denominator, or whenever we want to get rid of fractions, we use reciprocal to do that. Right. So we could multiply everything by y over y. But then if we did that, we'd also have to multiply 1 over x by y over y, and then we're going to have more y's over there. The other thing that we could do, well, there's one other thing that we can do, and that is multiply by the lowest common denominator. Remember all those years you had to find the LCD? Yeah, exactly, Elijah. So the lowest common denominator of x and y is x times y. So I think it's easier to actually do it and then see how that helps you out. So if I have x, well, so I'm multiplying everything on the left by the lowest common denominator, and I have to multiply that on the right too. All right, pen. Okay. What I have to do is my favorite property comes back, that distributive property. I have to distribute this to both the terms, right? So I'm going to have xy times 1 over x plus xy times 1 over y. Sorry for the weird plus sign. No, I just had a weird plus sign. equals xy. So we went from this nice, simple, elegant equation up here to a bunch of x's and y's, right? But it's actually going to help us out. So if I have x times y times 1 divided by x, I can cross off my x's, right? And I'm left over with just y. Because it's multiplying. I've got x times y times 1 divided by x. So I have an x in the numerator and 1 in the denominator. So I can cross off those x's, right? Yep. And then in my second term, I have x times y times 1 divided by y. So I can cross off my y's. And I'm left with x equals xy. Yes, exactly. You could. What we still have to solve for y. So the good news is doing all this is that we got rid of the y in the denominator. So that makes our life a lot easier, right? The not so good news is we still have a y in this term and a y in this term. So we're going to need to get those guys together and pull the y out. So we need a little bit more room. So we're going to have to keep going on this one. So we've got, I'm sorry for the overwriting, y plus x equals xy. I need to get the y's together, so I'm going to subtract y from both sides. So now I'm left with x equals xy minus y. So how am I going to get this y alone? Well, I'm going to pull out the y's again. So we're left over, if I pull a y out of xy, I'm left with x. And if I pull a y out of just y, I'm left with 1 times y. Okay, so this is like our two problems before. I have x minus 1 in parentheses times. Which step are you at, Elijah? Yep. So you're right here, right, Elijah, right in this one? Okay, so I am pulling y out of both of these. So if I pull a x out of xy, I'm left over with x. Okay, and if I pull a y out of y, you're still left with 1 because you have to, like if you redistribute this, you get xy minus y. So we get back to where we're at. Yeah. And Greta, you had a question too. Isn't x multiplied by y though? Which step is that at? Is that where it's at, Greta? Oh, up at the top? Sorry, I can't hear you. X multiplied by y because they are in the denominator. I'm trying to figure out if you're up here or over here. So when we're up here at this top, this is like we're multiplying. Oh, that's not what I wanted. we're multiplying by x times y over 1. Yes, it does, Greta. So it means x times y over 1, because we're just implying that it's in the numerator, right? So then when we multiply x times y times 1, okay, yeah, okay, perfect. Thanks for asking questions, though, guys. I appreciate it. Then I'm not just talking away. Where is she at? Okay, so we're back over here. We're actually almost there. We pulled y out of our two terms, and we now need to get y all by itself. And we're going to do that by dividing by x minus 1 on both sides. So when all is said and done, I get y equals x divided by x minus 1. These are challenging. These are like the tricky ones. So if you followed along with that, you can feel really confident that you'll have no problems with your homework. If you're like, I assigned 2 problems like this on your homework, but that's the 29 and 31. So, yes. It is not due Monday. It'll be due when all the homework is done, but we won't go over it in class unless you have any questions that you want to do. So this is like the teaching part of it. Yeah, it'll be due with all your chapter 1 homework. Yeah. Yep. So if you have time today and it's fresh in your brain and you want to go start 1-4 and get that done, that's great. And if you, yeah. I am going to switch up the homework maybe. No, I'm going to leave the homework like it is. So 7 through 15, 21 through 25, 29 and 31, and that's all odd. I didn't write odd behind each one, but it's 7 through 15 odd, 21 through 25 odd, and 29 and 31. Those are obviously odd. So 29 and 31 might be a little challenge. Try them. Bring your questions to class and we'll go over them. So this is the teaching part of 1-4. And then, like I said, now 1-4 is assigned, but please feel free to come back with questions about it. Okay. I was going to tell everyone. Oh, for those of you that missed it at the beginning of the help session, I'm kind of toying around with the idea of maybe if we have some teaching that we haven't got to, I might send out a video earlier in the week so you have more time to do your homework. So we might try that out next week, depending on how long class goes. I will let you know on Monday. Okay, thanks for bearing with all my messy screen here. I don't like to be a messy person, so it kind of drives me crazy. But yeah. But try those out and let me know if you guys need any help, okay? Anybody else have any other questions they want to do before we go? Any questions on this? You guys excited to go rewrite equations? I can hear the cheering from here. All right. Well, thank you all for coming today. Yay, see? Greta's excited. Thank you all for coming today. I really, really appreciate it. Have a wonderful Friday and a wonderful weekend, and I will see you guys all on Monday. You're excited for more homework. Oh, yes. Hey, there's less problems on this one. This one shouldn't be too bad. Have a great weekend. Bye, guys. Okay. Yikes.